Now we have everybody. Great.
Okay.
So let's try this out. Let's see how this will work out. First of all, before I start, let me just step around so you can see that we are actually here.
I will add also the audience
from Lausanne. It's a pity that we don't have a camera always pointing to the physical audience. Do we?
Yes, now.
Okay, now we have. Okay. So it has always been about 15, 20 people more than what you saw what you saw on the list of the online participants. So that's pretty good. It feels nice to be here with people again. And without further ado, I'd like to introduce basically the panelists. We have Brian Price. Has been already introduced in the invited talk in the first half. He's a researcher in Adobe Research, and he's probably one of the first people that did DocVQA before we call it DocVQA. Right. So very glad to have you in the panel. Dave Dorman has been around for as long as I remember, so he has a very broad, wide vision about document analysis research. So hopefully he will help us try to place in the map document visual question answering into what the ICDAR community is doing. Anand is coming from India, from IIT Jodhpur. He has worked a lot on DocVQA. He worked on DocVQA on book covers, for example, in the last ICDAR. So he's a member of our community that has been working on this subject for a while. And at last, here on my right is Philip Gradiński. I'll get it right by the end of the panel. Who's coming from Applica AI from Poland, a company that has been participating in our competitions, and they did pretty well with pretty much all the tasks that we have put to them. So,
except for this multi-document.
Except for the multi. Okay, there you go. We have something to break still. So hopefully they can give us some insights from the industry and also from the techniques aspect of things. So welcome everybody. Right. So as a sort of an introduction, we're an ICDAR, which is about documents and about reading systems, right? So it's about giving reading capabilities to machines, but VQA and DocVQA are about machines as much as they are about humans, right? So in reading systems, we usually forget that there is a human at the end of the process. We usually do, we extract information from documents, we do OCR, we detect tables, but the task, why we do all this, comes at the end. No, we don't know at the very beginning why we're doing OCR, right? At the time when you pass a document through whatever Microsoft OCR, you don't know why you're doing it. So the user comes at the end and it's disconnected from all this extraction process. No, so it's a conversion that we're doing more than understanding of the document because we don't know why. What exactly should we understand, right? So as such, I think that there are many different things to consider there. No, so one is of course understanding versus conversion. Another is online versus offline. No, we are used to do things offline. Yeah, let's go through the whole collection, convert everything to OCR, store it somewhere, and then we'll see what to do with it. No, whereas when you want to do things like VQA, you need to do things in real time. You need to have a dialogue with human, right? So I've seen a couple of times in the community where this has come up. No, in the human document interaction was one of the cases where we started looking at what the human actually wants. And I think DocVQA is probably a second time that this is really, the human is actually put in a central place here, right? So I wanted to start with just doing a quick round between all of you and ask you about how do you see this DocVQA topic? Is it just a fancy name? Is it a change of paradigm? We start, thinking about the final task. Are you here, all the physical participants, because it's a fancy name, or you're really interested in this? No? So I don't know if anybody wants to start. What do you think about DocVQA within document analysis? Dave.
Yeah, can you hear me okay?
Yeah.
Yeah, I was having some problems with my other computer, so I had to switch to an iPad here. So I first of all, thank you, all of you that have, I feel like sort of the outsider here because I haven't given a talk in this and I haven't really published in this, but Brian, both of you actually, this is great. From what I heard today, it was a great overview of what has been developed over the past decade, I guess, leading up to this point. So one of the things that dawns on me is we've always had the need for something down the road. In document analysis, yes, conversion has been sort of the need, assuming that we'd have tools to do the same type of analysis that we've done on text. But this is a shift in application of this type of work. Of course, in the sense of what types of techniques we're using, obviously, there's been a big change over the last half a decade. But making this explicit, I think, is essential. Making explicit some of these examples. I'm sure Brian, and Adobe, they have other applications that are, that are going to still use this type of downstream processing that are very different from the types of questions that you might ask or did ask in these competitions. One thing that I would encourage this community to look at is how the types of more general applications that the text analysis community has done, because basically we're going to, that's an important part. Now, the visual part, yes, it's a different domain, it's different information, but in general, things like summarization are problems that eventually would be useful for this kind of community. Could you take one of those infographics and summarize what it's saying? I can give you an example of something that we are involved with other projects, just trying to tell what those graphics are trying to do from a semantic media forensics point of view. Are they trying to portray misinformation? Are they trying to radicalize groups, things like that? So that's a different application, obviously, than answering an actual question. Across document summarization, for example, can you gauge the broad thoughts of the community in climate change, for example, by what types of graphs and what types of research are being put out? You have a lot of people working on this, and we saw today several things that were tables that were a conglomerate of information that came from a lot of different sources. Eventually, we would like to have our systems to be able to summarize across all of those different types of sources and be able to produce a state-of-the-art summary, or at least a table saying these different documents. So I think it's definitely moving in the right direction. But I think there's also a lot of things that we can be more creative on. And I have no doubt that'll happen, and we'll look back on this meeting a decade from now and say, yeah, we were moving in the right direction, and this is where we are now. So I think, from a general high-level document analysis community perspective, this is the kind of thing we need. We don't need more, binarization algorithms, and we don't need, more, OCR. Everyone today use tools that are out there. Yes, they enhance them some, but they started with the tools that are fundamental in document analysis, and I think that's going to be a key moving forward.
Thank you, Dave. Brian, Rand, anybody wants to take that? Brian.
I can go. Yeah, so this whole problem space definitely is very interesting. From my point of view at Adobe, Adobe owns Acrobat and PDFs, and it would be amazing if we could understand everything that's in those PDFs. Just maybe in just document understanding in general, just as one example, we recently came out with a PDF liquid mode. So I don't know if you ever try to read a PDF on your phone where you have to be scrolling all over and there's two different columns, or, it can be very difficult. And so there's just the desire simply to say, let's reformat the PDF to a single column like you would see with HTML, which is surprisingly hard. PDFs don't necessarily contain any structure information of, just figuring out which words follow other words, what the word order is can be very difficult. And that took quite a bit of work, just that. There's a lot of really interesting problems, specifically on the document VQA. It would be great, and I mentioned this in my talk, if, and when you bring up the little, find thing in a PDF, you can bring up your thing and you search for a word and you type the word network and it finds all the places that the word network is in your document. It would be amazing if you could start typing questions in there and have it go and find the answers to that and show you where it thinks the answers are. And that is, again, surprisingly difficult given the massive variety of things that can be in PDFs. But then, taking that to the next thing, we have enterprise customers that have huge amounts of documents. And again, being able to understand all the stuff is in those documents. If someone puts a query in and they have millions of documents, can we go find the right documents? Can we find the answer? Can we aggregate information across multiple PDFs is a very complicated and difficult question. And that goes directly into, why this question answering could be very useful. We all use, our search engines, Google or whatever our equivalent is, to answer questions all the time. And they're pretty good for the general web, but if you have your own set of documents you need to go through, it'd be great to have something more powerful for those.
Thank you, Brian. Anand?
Okay, thanks. First of all, thanks for inviting in this panel. Actually, if you look into the OCR, it's kind of highly underestimated. If it is a plain text, clean document, and then maybe OCR is nearly perfect, and you can talk about all these NLP algorithms doing well for question answering. So OCR plus NLP, right? But that's not the case, and especially if you look into documents, it has different authors or different variations. Either it is an infographics, or Brian was talking about charts, or SceneText, or even very complex magazines and all. So in those scenarios, it no longer becomes just do the OCR and ask the question. So you need to do much more than that. And I think for example, you may have to really interpret between these locations of this text, spatial location, and sometimes also may have to do some kind of a common sense reasoning and all. So where this is something which is makes it's very different from, distinctively different from OCR plus QA versus OCR VQA or DocVQA. Yeah, so of course, I think the way we are moving in this seems very promising.
Thank you. And Philip?
Yeah, I think first of all, it's really an enormously good idea to have this DocVQA datasets competitions, and it's really, for me, it's not just yet another dataset. It's a change in paradigm in thinking about, in NLP in general, because we really should start thinking, as you said, in terms of end-to-end applications rather than specific pipeline steps. Even for these OCR, I mean, you don't need from OCR perfect text layer, right? You don't need to have all the words, right, provided by the OCR. What you need is in many cases, in many end-to-end applications, is numbers, names, and so on. Sometimes weird numbers, right? Foreign names, weird names. So I guess it's paradoxically, it's still OCR is important, but we should think about OCR and other pipeline steps as kind of a, not as a target in an objective in itself, but kind of a tool for solving these end-to-end tasks, right? So I really like this. We really like this at Applica AI, this idea of this end-to-end task, and actually you might even try to solve it, purely using end-to-end approach, right? Without an OCR, right?
Right.
That's another nice thing, that you don't have to assume that you work on some some text given by the OCR. So for me, it's a beginning of an exciting journey, and as you all already mentioned, there are a lot of directions you can go, right? For instance, multilinguality. That's one, I guess, pretty obvious direction, but with all these variations, right? You can answer it. It could be a cross-lingual question answering. It could be just within the language. You could have not just multilingual data sets, but multilingual documents, like mixed languages or even writing systems, right? That's another case. In EU, we have, I don't know, 17 or whatever official, languages used in EU countries. So I guess that there are a lot of documents that could be used for preparing a data set like this. So there are so many directions you can go, like complex structured data, because sometimes it's very common in industrial applications when you need to extract not just simple texts, but some kind of data series or rows from table. But again, this is not because we've seen already many tasks when you're many competitions where your task is supposed to extract tables, all the tables, but it's not like this. We need some specific rows, but there might be multiple, like you have an invoice. That's a kind of obvious example when you need to extract the line items, right? So I think multilinguality, complex data, that's two examples of directions we can really follow from this. Yeah, so that's really cool.
Thank you very much, all. So I'm glad to know that you're here for a reason, not just for the fun.
Yeah.
So looking back into this DocVQA story, actually we started a few years ago with the idea that we should introduce reading capabilities to computer vision systems that try to do VQA in the wild, right? So back 2019, I think it was, we introduced the SceneText VQA in parallel with Amanpreet's group, the group of Devi Parikh, who introduced text VQA. And that has, it was very interesting, that from the document analysis community, we met in the middle with the people that were doing DocVQA, and they realized also that without giving reading capabilities to the system, there are many questions that are very, very difficult or impossible to answer, right? So then this moved into DocVQA, and we said, okay, so if we are doing that with a couple of words in the wild, why should we not try to do it with a full document? No? But of course, these are, although we're talking about reading capabilities, interpreting written information, written communication, there is also a big gap between these two domains. So we heard today about SceneText VQA, and we heard about DocVQA. What do you think is transferable from SceneText VQA to DocVQA, and what do you think is new in the document domain that we don't have in the case of scenes? I don't know, maybe Anand, you worked on something which is in the middle, with the book covers. I don't know if you want to start.
Yeah. So in case of SceneText VQA, you also have a strong visual prior, like you have a very strong visual cues, and and many times actually they are very, very helpful in saying the context also. In contrast, DocVQA is mostly text, right? So you have most of the things in the text, and very little of the visual cues. So I personally worked on actually both the directions, where we also worked on OCR VQA, where the challenge was to find out, given a book cover, who is the author or the editor and all such things. Major challenge there was like the layout analysis, complex layout analysis, which part is really referring to the title or and so on. SceneText VQA on the other side, majorly you have a fairly good text recognition because most of these fonts are quite, and of course it depends on data to data, but then you also have a very strong visual cues in SceneText VQA. So that is one challenge I see.
Any other views on this?
One thing that I'm sorry, Brian, I'll just mention now, I'll go back to sort of the motivation of what I was saying before, in that, you know, yeah, there's a lot of stuff in the text for document stuff, but there's also been like the chart infographics where you're extracting data directly from charts. I sort of see that as even a precursor to this kind of thing. It's just a module that you could put in there. But in general, I would push for the open problem of not just having a set of images that have text in them, but images that have, you know, that you can look at a set of images and make a decision and make a, you know, a conclusion. You know, again, from other domains, I have these types of examples, you know, but in general, you can imagine just taking a bunch of images from a Yelp review or something like that, and then asking something where sometimes you would have a picture of a menu that you could tell that's a document, but sometimes you might have just one of the signboards in the background, or you might have to put information from a couple of different documents together or images together to be able to answer these types of problems. I mean, even in the general text in the wild, you know, having a lot of images that don't have any text in them, just to make it a more general, realistic problem, I think is something that, again, I have no doubt that we're going to move in that way, but since we're sort of laying out ideas, I think that's something that we'll eventually get to.
Mm-hmm. So you mentioned that there is a lot of visual context, no, before in the case of SceneText, and now Dave, you're talking about documents where, in most of the cases, the information there is more explicit. No, I suppose that the visual information, the context that comes from the visual side of things, is more statistical in nature. No? It's more or less you have an idea about that you are in a restaurant. No, but when you look at the document, the structure is pretty explicit. If there is a paragraph, there is for a reason. If there is a line connecting two things, is for a reason. No? So it's, I suppose that this is a key difference that somehow we have to capture when in the image we have a document.
Yeah, in general, yes. But I'm just going back, you know, towards the, you know, the text in the, you know, in the wild. You could ask how much is a dozen oranges, and there's a thing that they're up there that says, you know, $5.99, but you don't, you know, you see bags of oranges there, or you see individual oranges. You don't know how many, you know, a dozen oranges are. So things like that. But if we look back at sort of what people do in the text analysis community, I think one of the things, and a lot of you younger researchers probably don't remember this, and it might be a, you know, something that delayed analysis of OCR text, but there was papers that came out that said, yeah, OCR works well enough that we can do information retrieval on documents. You know, we get a 10% error, we get a 15, 20% error. You know, current methods for indexing documents handle that. That might have been true when we had term vector type of analysis. But the community, the text analysis community, quickly moved on to entity extraction, to summarization, all of these other problems. And we were kind of left saying, you know, okay, well, maybe OCR documents aren't, you know, aren't good enough, or the OCR isn't good enough. So people still focused on that. Now that we're working on the PDF of Maryland is still an Oriole, but you can get that kind of context in the types of questions. And I think someone said it earlier that I think maybe it was Brian that said, you know, we want to ask, or humans are going to ask very general questions and not, you know, specific fill in the blank kind of things. And in order to be able to bridge that gap, we need to be able to, you know, do those types of deeper understanding of the documents.
Okay, thank you. Brian, Philip, any quick comment before we go
on? Maybe just reiterating what David just said. I mean, there is so much variety in the documents. If you think just, and like you had said, you know, documents are often meant to communicate certain information, just like photos in the real world might just be some random event, but, you know, documents, they're prepared to communicate certain things. And often they'll be very, you know, it's not inside of the text, it will be visual things. That's why when we publish our papers, we put in tables and we put in charts, because they communicate very densely some very complicated things in a way humans can understand. And we need, if we're going to understand that document, we have to understand those visualizations, because they were put in to communicate this information in a very, you know, visual way that humans understand, but that the documents may not. And, you know, these days when people are putting out all their tweets, you know, often even those will have multiple images, they'll have text, they might have little arrows. If we're really going to comprehend it, we need to understand that. I find the infographics really interesting. You know, that infographics can have so much variety in them, and they have these pictures and they have, you know, words placed in certain positions that communicate certain things. And there's just this, it's a hard problem.
Thank you.
And actually, an infographic is meant to be different. It should be different from our infographics. So it's quite, yeah, I would say that, yeah, I would agree with that. And actually, I think we sometimes forget that the document is created by humans for humans, right?
Yeah.
It's not, as you said, Brian, a random photo of something, right? Which was not created by humans in many cases. So yeah, and we sometimes forget that you know, the art of typography was created to encode information for human, you know, limited cognitive, you know, abilities, right? So I know somebody at some moment in human history, actually, I don't know when, invented tables, right? Tabular in yeah, I guess, I don't know. So it's actually quite, so our models needs to basically decode this information, which is structured in some repeated way, like chapters, paragraphs, or whatever. Yeah, that's where it's quite different. And
right. So you said that documents, I think Anand mentioned that documents are mostly text, but I think that we are clear in this panel that this is not necessarily the case. No? So when you say document, you probably need to verify it's signed. You probably need to understand what the different connections and the different graphics.
A book, a document is not just text. Yeah.
Exactly. Yeah. So, but there is a nice story there, because in the first task that we organized, the winning methods, we actually got very, very good results. And the winning methods were basically doing OCR plus NLP, nothing else. And the problem there is that the statistics were misleading, because we have loads of old documents that were mostly running text, right? So if you do OCR, more or less, it kind of works. But if you look into the failures, they failed in pretty much everything that was not running text, right? Handwritten text, big problem. Tables, big problem. Graphical elements, big problem, right? Structure, what is the title? Big problem, right? So it's, and I think that with the new tasks that we introduced, we kind of try to go that way. There are still two things that I would like to discuss with you very quickly. So one is explainability and the other is robustness. So one thing is for a system to tell you that the answer is 2. The answer is number 45, right? But why does it say so? No? Before, Philip, I think you mentioned about these Olympic rings. No? Yeah. It says it's 5, no? But why is it 5? Is it because it actually looked at the right place in the document to figure it out, or does it have a prior knowledge, or was it a random response?
Yeah,
no?
I think
and I link it also with robustness. No? So if you ask a question about about something on a big collection of documents, no? And it comes up with an answer. It says, okay, in table, whatever, in page number 45, I find a table that says this, and this is my answer. How do you know that it has actually explored the totality of the collection, that it has not missed anything?
Or just returns, you know, the
Yeah,
number given at
exactly.
a specific pixel on the document.
So I think that these are very, very important problems, and I wouldn't know where to start from, not only methodology wise, but also in terms of how do you structure the evaluation and the ground to test that this is the case. No, any comments on explainability and robustness?
I think that's kind of my hobby first. I mean, not explainability, but one thing that we quite often forget in academic community, and it's quite weird for me, that we forget about probabilities. I mean, confidence of our models. Actually, in practice, in this industrial application, this is quite obvious that our clients do not want just, you know, bare facts. They need probabilities to set up some threshold, you know, to decide whether it should be processed automatically or not. So actually, it's really important to be able to evaluate these probabilities or confidence score, whatever you name the GIF, and in other words, to assess the you know, the calibration, actually the confidence is also, you know, whether the model is well calibrated or not. Whether when it says that this, you know, this piece of information is extracted from the probability of 90%, whether it's really, you know, 90%, whether in 10 cases you extracted 10 data points with such probabilities, you've got 9 of 10, but not, you know, not 0, 5, or even 10. Actually, it will be miscalibrated if you have a model which says that 90% probability, but actually it's always correct, right? So yeah, that's so crucial, and I'm really kind of I think it's a mistake made by when you, and I'm kind of to blame, because I also dabbled in organizing, you know, some kind of competitions with the shared task, and that we just evaluate our models, whatever. Actually, it does not necessarily, it is not, you know, limited to this DocVQA or whatever other task, but actually any task in an NLP, we just evaluate, you know, the bare extracted text or whatever, but not the probabilities. That's the one. Obviously, this is not exactly explainability, but that's a kind of thing that is really quite often forgotten. So I hope next year we'll add some, you know.
It would be nice. It would be nice, but I need feedback. So how do we actually introduce explainability and robustness in our methods and competitions? And Ryan, Anand, David.
It's a great question. I'm thinking, you know, with the work that I presented earlier, there's no explainability. You know, the model says the answer is 5, and that might be the right answer, but it does not say. And we might think, yeah, you needed to take those 2 groups of bars and you needed to add them, and then you needed to take the difference between those, and that's not explained at all. Yeah, I think that's a really good question. I think as far as on a user side, you know, if it's a big corpus of documents and you're just pointing to, here's where I got my answer, a user can go and look at that. But for more an analytical approach of, you know, can we evaluate, is this thing actually doing the right thing? Or did it just pick up on some kind of bias in the data set? That is a good question. I think it would be, if we can make neural networks, you know, show their work better. Like, you know, kids back in school, you don't just write the answer to the math equation, you have to show all your work. Something like that, I think, could be very beneficial, but I'm not really answering your question. How do we do it? I'm not sure. That's a good question.
Great question. Any great answers?
I think it's a great question too. But you know, I think that back, this is not a plug for any particular technology that's not Google or anything. But when I ask Alexa a question, Alexa comes back and gives sort of a, you know, it doesn't just say like a Siri, for example, says, you know, here's a couple of links that might help you. Alexa comes back and says, according to XYZ, you know, over the next, if you ask about the weather this week, over the next 7 days, and I don't know if that's all templated or something like that, but I could imagine, extending what Brian was saying is, according to a chart in this place or this particular image, this bar plus this bar, whatever it is, but more semantically correct, suggests that the answer is something. So again, I don't know how to do it either, but I think we could have a more general framework for providing this type of evidence. And again, going back to the semantic media forensics program that we're involved in, it's just a matter right now of telling how you, giving a category of how you created it. That's as far as it's gone. So for example, if you say something, this image is not consistent with the text that's written there, why? And there's about a dozen different things from entities are different. The image appears to be generated. The text appears to be generated. The text is not consistent with the author, with the style of this author. So we could start by having some kind of an intermediate type of result. Did you get this from the text? Did you get this from a chart? As we get a more general type of thing of analysis of these documents.
Nice. There are some interesting pointers also in the text in the chat on this. Sorry, Brian, you wanted to say something?
I was going to say, one of the big problems is that we all use neural networks now, and they're so implicit in what they do. Often we don't know why they got the answer. If it is a big system, like you're trying to solve all the documents, I guess the more subparts you have, if you have a chart model for understanding charts, you have one for tables, you have one for images, that helps a little bit because you can at least say, we got the answer from this table, and you can point to the table. You may not be able to say how you got it from that table, but at least gives at least some information. The more that we create, one big model that does everything implicitly, it becomes harder. But often that's what works, is letting the models figure out everything implicitly. That's the tricky part.
Right. So when we started with this DocVQA thing, we thought that it would be a very researchy thing, exactly because there are very open questions like these ones. But we were at the same time very happy to see that many of the participants to all these competitions were actually companies, right? So two of the members of this panel come from the industry. So I'd like to know, why is the industry interested? Brian mentioned a couple of applications in the beginning. I'd like to hear from Philip as well. And more than that, how far are we to actually commercialize on this kind of things?
Well, actually, it's our core business, I would say, basically. So that's and to some extent, we actually commercialize this kind of applications. So yeah, that's basically.
So what is the application?
It's basically quite obvious. You have a document and you would like to extract some information from to turn a document, the information that is locked in this document into a kind of a database or database records or whatever. That's sometimes you work on a kind of a like limited or closed world when you have let's say invoices. I know that's a kind of a boring example, but when you have in invoices you have some seller, buyer, and line items, right?
Yeah.
But sometimes you work in more open world, and this is that's why also this DocVQA channel is so exciting, because in industry sometimes you work with clients with some open world stuff, and you have some insurance documents, and client would like to ask questions like, are car accidents covered by this insurance or whatever, like. So that's the whole range of possible applications of this. And by the way, speaking to also about this explainability, frankly, I'm a little bit skeptical about this. I mean, why I'm skeptical. First, it's as we know, it's hard. So now from an industrial perspective, because for academia, obviously, if something is hard, it's more interesting. But unfortunately, in many cases, people don't care about explainability. I mean, in some of it, yes, but if you want to extract some basic data from documents, in most cases, you are not interested from what it was extracted. You just need the data, and as I said, this probability confidence scores. There are more from my perspective, from let's say a more industrial perspective. This confidence score are more important than explainability.
Right, it's enough to build a model.
Yeah, business model. Yeah, obviously there are some cases where this is important. Yeah. Okay. Yeah, so that's the stuff, because that's a lot of information. You might say that it's going to be outdated, because now we are switching to fully digital economies and so on. But still, first, I think we are still in a kind of a peak paper, right? In the time of human history, but probably now or around now, there is the largest number of paper stuff still, even for of this digitization and so on, right? And still there are, and obviously in many companies there are a lot of documents, archives, thousands of documents, and that's in many cases business actionable information is there to be extracted.
So the way the state of the art is right now is already enough to build an industrial.
Yeah, I mean, obviously not. No. There are some problems you cannot solve. It's quite obvious, but yeah, that's still it's
commercializable.
Yeah, you could at least commercialize it, at least some of these ideas, and that's why it's so this area is so exciting, because it's happening so
nice.
And so this DocVQA is really
things seem to happen very fast then.
Yeah.
So are we going to see VQA integrated with Adobe anytime soon, Brian?
Oh, I don't know if it'll be anytime soon. I hope that someday we will. I mean, the interesting thing about Adobe is we basically gave away PDF a long time ago. You can create a PDF and read the PDF without using any of our products. And so if we want to make money off of it, we need to provide some kind of services or something that will make it worthwhile. And we do have a number of services, but yes, the more that we can provide those really intelligent services that others aren't providing, or at least be providing ourselves, that adds to our portfolio of services to get people to pay us. So it is there's businesses have tons of documents and individuals have them, and there's needs, a lot of big actionable things that are in those documents. And so the more that we can provide there, the better for us commercially.
And for the research members of the panel, thinking about more futuristic applications in the future, are we going to be able to talk to our books or something, or what kind of new things would this new paradigm open?
Yes. So maybe may I answer?
Yeah, Anand.
Okay. So two things, two challenges I was seeing is, one is this kind of like lack of data or like self-supervision. Like you can, we are coming with nice data sets. Can we automate some of these data sets creation? So for this direction, we have some work, which is like, again, this is kind of a promotion. It's appearing in this ICDAR. I think it's on 9th, just a minute. It's a presentation on oral session 6, SceneText detection and recognition, where we talk about generating questions out of images and images containing text. So can you automatically generate some questions, and such can also lead kind of providing some self-supervision type of things. Mm-hmm. So that is another thing which our group is looking currently is kind of this bringing some kind of a common sense reasoning.
Yeah.
right? So in this question answering, so for example, let's say you have two queues of people, one in front of KFC and one in front of some airline counter. Just from visually looking them, it looks like they are like queue of people. But maybe from this reading text, we may able to say like these are the queue of people for fast food, and this is a queue of people for maybe taking tickets. So that is one. These are the two things which we are exploring. Yeah.
Thank you. So we're already running 4 minutes late. Let's see if there is any questions from the audience. Anything you want to ask the panel or the online audience? Otherwise, maybe 30 seconds for a last comment if you want, every one of you, and then I think we should close the panel. Dave, any last comments?
Just in general, I think this is really great. I'm very pleased to see the progress that's been made in this area over the recent challenges. One thing that I would suggest is that maybe we try to, and Demos, I'll this is something that I know is passionate to you, but if we either get to have these types of meetings on an annual basis because of how fast the other communities are moving, or we start putting this out where we can associate it with other meetings other than ICDAR, I think we'll see even more progress and more groups that are participating in this area, and I think we'll all benefit from it. So my vote is to go full force, not with just the documents community, but let the other communities contribute as well, because I think they will, given the amount of effort that you put into all of the data and all of the organization of this.
Great, thank you very much, Dave. Anand, any last words?
Yes, so yeah, once I agree with David that we are definitely moving in a very right direction, and these data sets especially are enabling research. So we may also have to look into some other angles, like multilinguality is one thing, which can be also cross-lingual question answering, especially where the data is in English, but you can ask questions in your native language, and so on. The other part, which is also really missing, not missing, but people are really doing that also, is this kind of numerical reasoning and all such thing, which requires where the current models are not sufficient, perhaps. So these are a few things.
Perfect. Thank you very much, Anand. So Philip is nodding his head. 30 seconds statement.
Thanks for the data set. It's really for the challenge. It was really exciting. My colleagues were really they were working every day and so excited about this and coming with some new ideas how to tackle this challenge. It was one of the thanks. Thanks for your effort. It was really great.
You're very welcome. Brian, last words.
Just thanks to everyone who's working on these problems. I think they're very interesting and very challenging, and the more headway we can make, the better. There's, and keep in mind too, I've heard people say, often in computer vision, people are trying to solve data sets and not the real world problems. So the more that we can try to solve the real world problems, the better, which means more data as well, make the data sets bigger. Being able to specialize on things like academic publications is great, but that won't work once we want to run it on magazines. And so also the more variety, these big data sets are really important. We need more of these and continue increasing the variety so that we can, tackle the real world.
Right. Perfect. Thank you very much, everybody, for the very lively discussion. Thank you very much for attending online or on site, and enjoy the rest of the ICDAR conference. Thank you. That's it. Thank you very much.
Thank you.